Hey everyone, welcome to Microsoft Ignite. I'm Jessica Dean, and I'm here in my home office with several Star Wars and Disney collectibles behind me. I'll be presenting with Lavanya Casarabata, who is in her home office, with a door and bookcase behind her. Today, we will focus on how to build secure apps with collaborative DevSecOps practices. Let's do a brief overview of our agenda. We will cover the evolving threat landscape, Microsoft's DevSecOps solution, how to secure your development environment, how to embed security in your developer workflow, how to foster collaboration, and at the end, we'll review some next steps. Enterprises can no longer wait to address security. It only takes 3 days. 3 days for a hacker to exploit a vulnerability, leaving security teams little room for error in their response. In just 3 days, you need to identify all the applications using the vulnerable component and ensure all those code bases have been updated with secure dependencies. The threat landscape has been changing over the past few years, as hackers now shift left and compromise upstream dependencies and engineering systems. The result is that these attacks can impact entire development environments and software supply chains. We saw this in the case of a software vendor, where an attacker targeted their developer workflow and software supply chain. The attacker was able to not only gain access to their cloud storage account, but also upload a new image into thousands of builds that scan their software supply chain, extracting even more secrets and widening the breach. Another example is of a leading game publisher, which recently had source code from one of their games stolen due to stolen cookies that contained Slack login information. They didn't have the secret or identity protections needed, and these vulnerabilities became an easy target. In order to remediate threats as early as possible, it's time to shift security left and unite teams. Many organizations are just beginning this element of their digital transformation. Currently, 62% of enterprises do not integrate security in the development phase. And further, 58% of security and development teams do not even collaborate. When organizations don't start security processes early and involve all their teams, they not only lose visibility across the business, but they also often take much longer to locate and remediate vulnerabilities. Shifting left helps enterprises find and remediate vulnerabilities earlier and across their development lifecycle. Enterprises that extend security to development reduce security incidents by 80%. And it's not just a reduction in events. There's also a financial component here. It costs 60 times more to fix a security defect in production than in development. Now, how do we start shifting security left and moving to cloud-native environments? I am so glad you asked. Let's talk about Microsoft's DevSecOps solution. Microsoft's unified DevSecOps solution relies on 2 main components. The first is making sure we are securing the developer workflow as code is being created. And the second is security operations, which tends to the code after it's deployed in production. Let's dig into the development section first. We have an extensive solution thanks to GitHub and Visual Studio. Visual Studio Code is by far the most popular code editor. It is lightweight, yet powerful, and it is designed for every developer working on every programming language. GitHub Codespaces is essentially an entire development lifecycle tool in the cloud. Codespaces makes it super easy to securely onboard new developers to your team and work with contractors or third parties. GitHub Actions helps development teams easily create workflows to build, test, package, release, and deploy the code to wherever they want. Finally, we have security guidance and continuous feedback through GitHub Advanced Security, which includes code scanning, secret scanning, and dependency scanning. We've also compiled a strong, unified set of SecOps tools that helps you manage security posture and proactively defends against threats. For identity management services, you can use Azure AD to instill a zero trust security throughout your organization. You can leverage Azure Policy to systematically enforce policies across applications and projects and to assess compliance at scale. With Azure Security Center, you have all the tools necessary to anticipate and remediate threats wherever your applications live. And with Azure Centennial, you have access to intelligent security analytics that provides you with a bird's eye view across your entire enterprise. All these capabilities fully integrate with one another, and when deployed together in Azure, makes a complete unified solution for secure development. This unified DevSecOps solution makes it easier for organizations to realize the key DevSecOps benefits of securing your development environments, easily allowing you to embed security in your developer workflow, and helping foster collaboration with shared accountability between the Dev and SecOps teams. Let's dive into each of these topics a little further. We'll start with securing your development environment. Securing the development environment begins with securing all developer machines. That means we need to place more strict controls on how developers especially interact with non-trusted code. For code browsing, we should limit scope for non-trusted repositories to a browser sandbox. We also should only build non-trusted repositories in an isolated environment and never on a local development machine. And identity policy management is important too, as cloned repositories should implement least privilege access principles. When implemented correctly, you're defending your organization against common attacks like executing malicious code on dev machines and hackers using compromised developer machines to act as a jump box to further systems. GitHub Codespaces provides your developers with a sandbox environment to securely interact with non-trusted code. GitHub Codespaces is a cloud-powered development environment that is available anywhere and on any device. And I mean any device. By launching Codespaces in the browser of your laptop or your iPad, you will be ready to code in seconds, instead of spending hours or potentially days setting up a dev environment. It also provides familiar tools and a consistent experience for all project members across the board. It's a super easy way to provide an on-demand development experience for all developers. It's also on a secure environment, which has a very detailed login and a lot of encryption address capabilities. It helps organizations manage user permissions, get access to encrypted secrets, and make sure that they're stored in the right manner. You can also use GPG verification to ensure commits are being verified and are made by trusted users. It provides a lot of flexibility and efficiency while providing security, compliance, and productivity enhancements for your organization. Along with dev machines, you'll also need to secure your DevOps pipeline. In order to ensure development security alongside developer velocity, you'll have to make sure you implement a centrally governed and secure engineering system, controls so that only trusted, approved, and authorized DevOps pipelines and actors have the ability to enforce supply chain controls, and ensure that your deployment from non-trusted pipelines will be controlled by denying production certs. These changes will fortify your organization against threats like compromised build machines, compromised dependencies, and unauthorized access to package repositories. Now I'd like to show you a demo of what GitHub Codespaces is, how it works, and how easy it is to set up. Let's talk about what happens when you want to make a change to your code, or you're working on development and you want to make some simple updates. Now, if you want to update a single file, you can drop down into wherever that single file is. For example, here's our solution file with our Tailwind Traders front end. I know I can edit from within the browser, but not only is this incredibly limited, it's a little impractical if you're making a lot of changes or if you need an actual development environment to not only load all your files for your application, but also to run, test, and debug properly. Not to mention, editing in this manner is not recommended or secure. Another option is you can use github.dev to bring up a Visual Studio Code-like interface. You can do this one of two ways. Since we're already looking at our project within our browser, we can head over to our address bar and type in github.dev. Simply replace the .com with .dev. An even easier option, however, is to hit the period key on your keyboard. This will take you directly to the GitHub web editor instantly. You'll notice by looking at the URL for this page, the only thing that changed was we have github.dev instead of github.com as the prefix. This certainly looks great. It's definitely an improvement over the single file edit option. I can see I now have a folder tree with all my application source code, and I can drop down into these files. For example, here's my Docker Compose file, and this looks better than our previously not recommended edit option, but this is still incredibly limited. For one, you may notice we have a message where our integrated terminal would normally be if we were using Visual Studio Code. We are informed terminals are not available in the GitHub web editor. You will need to continue in an environment that can run code like a Codespace or local VS Code. Another feature we do not have access to in this simplified web editor is our debugger. Again, when we click our debugger tab, you'll see we get the same error informing us we need a development environment, something with compute. Further, as developers, we tend to rely on our extensions. You'll notice I don't have any installed extensions. And if I did, the lack of a terminal or ability to run, test, and debug our code really limits us. As the terminal message indicates, I can simply switch over to a local VS Code instance and proceed to develop as usual. However, in the spirit of shifting left in security at the earliest possible moment, using a local development environment is really counterproductive to our end goal of ensuring a secure development inner loop. This is where Codespaces comes in. Codespaces allows you to build non-trusted repositories in an isolated on-demand development environment instead of relying on your local development machine. This helps us ensure an organizational defense against common attacks, such as the execution of malicious code on local machines and hackers using those local dev machines as a jump box to further systems. Now, you may be thinking, I need to be agile. I don't have time to set up a whole new development environment in the name of security. First, with that perspective, you'll either need to make time to mitigate a security issue in a reactive way once one is found, and one will be found, or you can shift left and make the time to do all you can now to prevent a security issue from surfacing in the first place. Second, what if I told you the setup of this isolated development environment completes in less time than it takes to make a cup of coffee? There are two ways you can configure your code space. Like using github.dev, you can set up a code space right from your web browser. To do so, navigate to code. This is where you would normally grab the URL to do a git clone. Only now you'll notice two tabs, Local and Code Spaces. From the Code Spaces tab, click New Code Space. And from there, you can choose your development machine type, 2-core, 4-core, 8-core, etc. For this example, we'll choose something reasonable like 16 cores. Kidding. Let's grab 4 cores and we'll click Create Code Space. That's it. GitHub will do the rest for you in a matter of minutes. Now, you may prefer to work within VS Code, as do I. Let's see how quick and simple it is to create a code space here. Head on over to Extensions and search for code spaces. You're going to want to ensure you have the Codespace extension already installed. If you don't, go ahead and install it. Once you've installed it, you'll need to bring up your command palette. I'm on a Mac, so I'll hit Command-Shift-P. But if you're on Windows, you'll hit Control-Shift-P. From there, type code spaces and navigate to Create a new code space. You'll be asked to select a repository. In this instance, I'm using an organizational repository, so I'll type that in and hit Enter. I'll select my branch, which is this debug login problems branch, as that's an active problem our team has been working on. And finally, I'll have to select the machine type, just as I did previously. That's it. Your code space will be created and you'll be off to the races. Now, I want to show you just how customizable Codespaces really is, how it truly is an isolated development environment in the cloud. Here's my code space I set up for this project. And you'll notice how even my terminal has my own customized dot files. I love me some pretty dot files. Now, to prove this isn't my local system, I'm currently on a Mac, but within the terminal, I can type lsb_release-a, and you'll see my code space is running on a Debian Linux compute box or compute container. If I head on over to the Extensions tab, you'll see I have access to my installed extensions. And since this is a full development environment, I'm able to run, test, and debug my application just as I would if this code were local on my system. I can hit F5 and debug normally, without having to install any specific versions of .NET, React, or any other tools needed for this application, as Codespaces provides all of that for me. You'll also notice I have a new tab here labeled Ports. These are automatically configured for me, again, thanks to Codespaces. So I can access my application, hit breakpoints, step in, step out, all with an incredibly native experience. The last thing I want to show you is how portable this experience really is. I'll stop my debugger here and we'll head back over to my browser. I have my Codespaces environment already up, and my files are the same. My extensions are the same. And even my terminal is identical to the configuration I just used within VS Code, because my configuration is not dependent on my local system. It's all stored securely and safely within GitHub Codespaces. If I hit F5 again to start my debugger, you'll also notice I don't have to worry about port forwarding, because GitHub even gives me a fully qualified domain name to test and see my application, regardless of where I'm developing it. Thanks to GitHub Codespaces, I can comfortably and securely develop anywhere. Once we have secured our development environment, let's move on to how we can embed security in our workflow. When we look at where security fits into the development lifecycle, there are different components for each stage. For pre-commit, we want to focus on threat modeling and understanding the threat landscape and the overall risk of what we're looking to bring to execution and code. We also use IDEs, security, plugins, and pre-commit hooks to make sure that the code we're generating adheres to the security standards and we're not creating any vulnerabilities unintentionally. We also make sure that there are peer reviews. Peer reviews helps us get on the same page about the security risks and code we're introducing into the code base. When it comes to the commit stage, this is where we start taking on more extensive security methods to review the code, including static code analysis. We also review dependency management and the overall dependency tree for inherited vulnerabilities. This is also when we look at the credentials that may have been inadvertently introduced into the code base. This is called credential scanning, but may also be known as secret scanning, token scanning, or cred scanning. In the deploy section, we look at the infrastructure as code, IAC. For example, ARM, Azure Bicep, or Terraform templates, which are increasingly used for automated continuous deployment. We do security acceptance tests to make sure everything is in line with the expectations and organizational security goals. Once code is being deployed, now it's a matter of operating and monitoring through continuous monitoring and additional threat intelligence, which not only helps us see current results, they cover the overall dependency vulnerabilities that we may be inheriting over time. We also do additional postmortems and make sure that we can take away some lessons learned and that we're continuing to iterate as we go through the DevOps cycle. In order to make securing the code easier for developers, GitHub Advanced Security provides native and automated capabilities to provide continuous feedback on security fixes through the lifecycle. GitHub Advanced Security is a developer-first, community-driven approach to overall security. It consists of three main capabilities. First, dependency scanning that gives you an idea and the risk levels of the dependencies you're using. We also provide automated fixes to vulnerable dependencies you may have in your code base. It's a continuous process that nudges the developers in the right direction in a friendly, non-obtrusive way. The second capability is code scanning, which is extensible to using third parties. The secret sauce is all scanning takes place as code is being generated, without any additional steps to ask for code scanning or to run at a separate location. All scanning takes place, and then the results are published in the familiar GitHub user experience. It's very easy for developers to fix early in the lifecycle. And the third is secret scanning. Again, secret scanning scans the code for hard-coded credentials or tokens. It provides an easy way to manage these issues. GitHub Actions helps your development teams easily create secure and automated workflows to build, test, package, release, and deploy apps to Azure or any other cloud. Azure provides a rich set of GitHub Actions integrations that helps you adopt an everything is code DevOps model, where not only infrastructure, but also compliance and security policies, build and release pipelines, etc., are all written as code, enabling continuous improvement and promoting better reuse and driving greater transparency. Some of the top security-related GitHub actions are orchestrating policy integration for managing Azure policies as code from a GitHub repository, scanning containers to look for common vulnerabilities in Docker images before pushing them to a container registry or deploying them in a containerized web app or Kubernetes cluster, and managing secrets using Azure Key Vault so you can dynamically pull secrets from an Azure Key Vault instance for consumption in GitHub Actions workflows. It's common for hackers to target development environments and use discovered credentials for source code tampering and injection of malicious code. Currently, your development teams need to store their Azure Service Principal secrets in GitHub, which is clearly not only redundant, but also highly risky. I am excited to announce the preview of capabilities that enables developers to secure their deployments to Azure through OpenID Connect integration between Azure AD and GitHub Actions. The new capabilities alleviate the need for managing Azure Service Principals and other long-lived credentials in the GitHub Actions secret store. This also means that you can manage all cloud resources access securely in Azure. These capabilities also minimize the chances of service downtime due to expired credentials in GitHub. Now let's jump into a demo of GitHub Advanced Security in action. Tailwind Traders has begun to shift left when it comes to security, and we want to show you what we've learned and how easy it is to get started with GitHub Security and Advanced Security. Let's start with our front-end repo, Tailwind Traders' website. We'll head to our Security tab, and you'll notice everything is green and active. Great. Let's drill down into what some of these features are doing, starting with Dependabot alerts. Dependabot alerts will notify you when one of your dependencies has a vulnerability. Let's click View Dependabot Alerts, and you'll see we currently have 67 alerts we need to address, all ranging from low to critical severity. And while this isn't great news, it's terrible in fact, it is good we have this level of visibility so we can plan our sprints accordingly to mitigate these concerns. If we want to understand our dependencies even further, we can click the Insights tab and head to Dependency Graph. Here we can see an alert regarding the security vulnerabilities, as well as all dependencies defined within our manifest files. Now you can access security features inside of GitHub by either clicking the Security tab, as we have been, or you can see additional features under Settings and within the Security and Analysis tab. We've already seen Dependency Graph and Dependabot alerts in action, but we can also take advantage of Dependabot security updates. This feature allows GitHub to open a PR with a patched version of your dependency after an exploited dependency has been found. In fact, if we navigate to the PR tab, you'll see we have a few PRs Dependabot opened already. We have bump PRs for merge deep, TMPL, color string, and path parse. We can drill down into any of these and see the Dependabot bot commented on the PR, and we can confirm all our checks have passed. This is great. Heading back to Settings and then Security and Analysis, we can take a look at GitHub Advanced Security. GitHub Advanced Security enhances these security features even further and helps us in our quest to shift left. Let's start with code scanning. Code scanning will automatically detect common vulnerabilities and coding errors, which helps us be more proactive as we develop. This is great. In fact, I got a ping earlier, there is a PR that requires my review. Boz, an engineer from our team, has added support for searching using product type codes. Awesome, that sounds great. Only I can see here, one of our checks failed, and it's our CodeQL scan results. If we take a deeper look into which files were changed, we can see on line 98, we have an error for a SQL query built from user-controlled sources. We can drill down into this by clicking Show More Details, and we can see the specific compromised code and why this code is compromised. In this case, it's vulnerable to SQL injection. Code scanning flagging this SQL injection vulnerability during a PR review is a great example of shifting security left. Boz has already been expecting a code review from his peers, or in this case, a bot like CodeQL, And he probably has the code open on the right branch in his IDE or his code space. This makes fixing a vulnerability right then and there cheap and easy. The problem can be addressed before the vulnerable code is merged into the main branch, and it'll never get anywhere near production. This saves us both time and money as we prevent ourselves from having to retroactively respond to a vulnerability after the app has already shipped. Heading back to our security tab, let's talk about secret scanning. Secret scanning will scan for known types of secrets in an effort to prevent fraudulent use of secrets that were committed accidentally. I can see on the left-hand side here, I have one alert for secrets detected. When I drill into this, I can see an Azure storage account key was detected, and drilling in even further, I can see the specific file where the secret resides. Armed with this insight, I can take immediate action to rotate and subsequently revoke the compromised secret. Now, we have two repositories for Tailwind traders. We have our front end, which we've focused on up through now, and then we have all our backend services. Let's take a quick look at our backend repo. If we drop down into the deploy folder, you'll notice we have a folder named Helm. Helm is the de facto package manager for Kubernetes. And this folder holds the declarative syntax for what each component of our application needs. We use Helm to easily deploy each one of our Tailwind traders' backend services. We can see we have the cart API, the coupon API, image API, and more. Now, if we head back to our project's root folder and we look at the source folder and then drop into services, we'll see we also have codebase that lines up with those same services we saw in the Helm folder. This is a lot. We've already turned on all the necessary GitHub security features, but what happens next? Once our code and dependencies have been updated and all the scans are green, and then we build these container images and push them into Azure, how do we continue to ensure security is central to our process? I'm so glad you asked. From within our Azure portal, we can navigate to our container registry and then click on the security tab on the left-hand side. From there, we can see immediately which recommendations exist for our repository, a description of the issue, and the severity level. We can click on any of these to get more information. Clicking on the top option will allow us to see the vulnerabilities detected in our container images. Here we can see there are 3 findings that apply to various numbers of our application images. Again, we can drill down into any of these findings to see more information, including remediation suggestions if available. I also have the option to take action right from within the Azure portal. By clicking the button to take action, I'm directed to a bird's eye view of the different repositories within my Azure Container Registry. I can see clearly there are 9 unhealthy repositories and 2 healthy repositories. You'll notice we have a column labeled CI/CD Critical Findings. Remember, CI/CD stands for Continuous Integration and Continuous Delivery. This column allows us to trace which CI/CD GitHub Actions workflow built the image in question. At this time, we can see Tailwind Traders has not yet enabled this feature, but Lavanya is going to teach us how to do that later today. Over to you, Lavanya.
Thanks, Jessica. Now that we've seen how you can secure your dev box, secure your dev workflows, and view these security results in GitHub, let's see how we can enhance the communication line between dev and SecOps teams. Historically, developers have tracked deployment and shipping speeds associated with pipeline throughput. However, for shared accountability along with pipeline throughput, it's important to focus on metrics that deal with lifecycle health. Generally, the most critical metrics to track are time to detect, time to communicate, and time to mitigate security issues. Focusing on these 3 metrics allows your organization to lower the time to respond to vulnerabilities within that crucial 3-day window that Jessica mentioned at the beginning. I'm also excited to announce version 3 of the Azure Security Benchmark with a new set of controls for DevOps security. Azure Security Benchmark is Azure's own security control framework based on industry standards such as CIS, NIST, and PCI. The new DevOps control family provides you with concrete guidance on how to secure your CI/CD environment and meet the security control requirements of your organization. We're also enabling monitoring of these guidelines in Azure Security Center Regulatory Compliance Dashboard. This enables you to get a compliance view of your production as well as your CI/CD environment at the same place. At Build, we announced GitHub's integration with Azure Security Center, where we're providing the shared tooling and observability these team leaders need to kickstart DevSecOps practices. Now, we're taking our first steps towards building that shared tooling and experience by extending the reporting from container scans into Azure Security Center, providing security teams better insight and understanding as to the source of vulnerable container images and the workflows and repositories they came from. This helps developers scan for common vulnerabilities in their Docker images before pushing to a container registry or deploying to a containerized web app or a Kubernetes cluster. Additionally, Azure Security Center will be able to recommend CI/CD scanning to any images that are scanned in a container repository that do not also show a CI/CD scan result. As expected, Azure Security Center can provide recommendations on remediation for these affected images, giving the security team a way to provide actionable feedback to the development team. Now let's jump into the demo of GitHub integration with Azure Security Center. Here we have the Tailwind Traders full CI/CD GitHub Actions workflow. This is the workflow Tailwind Traders uses to deploy our application to our various environments: dev, staging, canary, and ultimately production. We have three main stages or jobs within this workflow. The first stage or job deploys our infrastructure. You'll notice there are only a handful of steps involved in standing everything we need up. The reason we were able to keep the state so simple is because we utilized Azure Bicep to declaratively stand up the necessary resources. Azure Bicep is a domain-specific language used to define the desired Azure configuration, and it works by letting Azure Resource Manager provision what has been defined. What's neat about Bicep is this deployment isn't only standing up our infrastructure, it is simultaneously ensuring our infrastructure is in alignment with corporate policy. It's accomplishing this by deploying Tailwind Traders Azure policy definitions and assignments right alongside our other Azure resource objects such as Azure Kubernetes Service, Azure Container Registry, Azure Key Vault, and database servers, etc. Once our infrastructure has been provisioned, we can proceed to our next stage or job. This is the stage where we build the images we need for Tailwind Traders. You can tell what each step in the stage is doing by the name of the task. We're checking out our code, we're building Docker image for each individual API. Once our images are built, we also push those images to our container registry we saw previously. The final stage is our deployment stage. This stage handles the delivery of our application to our necessary environments. Similar to the build stage, you'll see a step for each one of our microservices. You'll also notice, as I mentioned earlier, we're using Helm to deploy our application to our Kubernetes cluster in Azure. Our current workflow works well and deploys everything we need for Tailwind Traders storefront. But as we saw in our last demo, we have vulnerable images in our container registry. And we also have zero insight into which CI/CD workflow pushed those compromised images. Let's take a look at how we can wire up the CI/CD critical findings and gain even greater traceability into the health and security of our application. I'm going to start from my preferred IDE, Visual Studio Code. I have my Tailwind Traders backend repo already up, and I've opened up my pull request workflow YAML file for my cart API service. This is the workflow that fires off every time a pull request is opened with a change of that service. As part of the defined steps, we build our Docker image, push it to Azure, and then deploy the single service into a PR namespace on our development cluster. We'll learn more about that later today. For now, I want to add in two steps. The first step I'll add is a scan image task right after we build our container image. This will allow us to get scan insights directly from within GitHub as to the health of our image. After the scan is complete, we'll push the image to Azure and we'll add our second step. This step will publish our container scan results to Azure Security Center. That's it. Those are the only two modifications needed to wire up GitHub Actions to Azure Security Center for container images. To test this, I'm going to check in some changes I've already made to the cart API. You'll notice I'm doing all of this from Visual Studio Code, including opening a pull request. Opening a pull request is what will trigger this updated workflow. Let's check on in the progress. Awesome. I can see our workflow is running and it's just about complete. Perfect. It completed successfully, only now I see a red X on the left-hand side. When I click on it, I can see the container scan results right here as part of my build report. I can see the specific vulnerabilities contained within this image, and I'm even informed of the best practice violations. Based on this information, we can make actionable decisions to mitigate these concerns in our next sprint. Heading over to Azure Security Center and drilling down into the CART API repo within our container registry, I can see clearly how a CI/CD scan has been found for our recent push. Drilling down into the scan report for this image, I now see the same insights here in Azure Security Center as I did in GitHub Actions container scan report. In fact, when I hover over the icon to the right of the CI/CD scan findings, I see CI/CD pipeline info, including deep links to the repository, the run, branch, and even commit. This is fantastic. Now, we only implemented this report for this particular PR workflow, but now we can take the steps we've learned and enhance our full CI/CD workflow to give us the same traceability we have for our pull requests. Now, over to Jessica to conclude this session.
Thanks, Lavanya. It's so cool to see how easy it is to bring GitHub Actions and Azure Security Center together. Let's now wrap up our session with a brief review of the journey we've been on together today, and then we'll move on to some next steps. To summarize, with GitHub and Azure, it's never been easier to kickstart and scale your own DevSecOps practices with our unified solution. This complete toolset offers so many ways for you to integrate security into your development lifecycle, proactively manage threats with continuous observability, and foster collaboration with shared tooling. Embracing DevSecOps is a software delivery advantage. You get to remove bottlenecks clogging your delivery pipeline and provide the necessary controls for compliance and security. By uncovering vulnerabilities earlier, your team saves time remediating issues and realizing compliancy while also minimizing any associated costs. You get to return to what's important, propelling innovation with efficient and secure software delivery. If you'd like to learn more about securing software development with GitHub and Azure, head on over to aka.ms/DevSecOps Ignite 21 blog. Again, that is aka.ms/DevSecOps Ignite 21 blog. You can also download the DevSecOps paper to learn more about the best practices on integrating continuous governance, security, quality, and compliance into your engineering processes. Finally, thank you so much for hanging out with Lavanya and I today. We wish you a fantastic time here at Microsoft Ignite. Take care.